Hello everyone, this is Udit again from TechSpark, bringing you another session covering data engineering Q&A. And in today's session, we're going to talk about AWS Glue ETL. So before starting off, I'm going to give away my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an intermediate profile with a comprehensive course covering all the necessary topics of data engineering. So AWS Glue ETL is a service solely provided by AWS, and this is quite similar to PySpark API that we have worked. The only difference is the PySpark or Apache Spark, for that matter, can run on any environment or platform. So if I want to run it locally in my machine, that's possible. If I want to run in any Hadoop cluster, that's also possible. And if I want to run on AWS EMR cluster, which I showed you in the previous video, that is obviously also possible. And there are numerous other services or numerous other platforms which is supported by AWS, the Apache Spark, such as Azure, GCP, or even Kubernetes. But if I talk about AWS Glue, and most importantly, why would I need to know about AWS Glue if I'm saying that this is similar to PySpark API, which is already available across all the environments? Is the reason is AWS Glue is absolutely serverless. Okay, if I talk about the ETL jobs, I don't need to spin up a cluster. I don't need to log into a remote host and then set up everything and then Spark submit my API. These are things already have been taken care of by AWS, meaning over here there won't be any as such putty or any other remote host where I need to access to, and then I have to drop my script and then run it. Okay, I can simply have the script in my AWS S3 bucket and then run it directly from AWS Glue. So AWS Glue is a serverless service, and it's also a bit cheaper than EMR, and that is the main reason why Glue ETL is something that some of the industries or some of the projects tend to shift from the obsolete or the regular EMR clusters or the on-premise clusters to AWS Glue servers. Okay, so now let's look at the overview. So AWS Glue ETL is a serverless service that automates the process of extracting, transforming, and loading data from various sources to destinations like data lakes, warehouses, and databases. So it's similar to PySpark, right? We are doing the same sort of processes in the PySpark API as well. In fact, PySpark is also supported in AWS Glue. Though there is a native API that is the dynamic frame API, I will talk about it later, which is kind of like the entry point to the AWS Glue ETL jobs. So the different components which comprises of the Glue ETL is one is the Glue data catalog, which we have already talked about in the last session. Then there's Glue crawlers, which we have shown a demo of in the last session, right? And then the other one is the Glue jobs. So Glue jobs is the one that we would be talking in this session, and in the next one I will show you one demo script how to run it using Notebook. Right. So if I talk about AWS Glue catalog, Glue data catalog, so this is just a centralized metadata repository for all the data assets. Okay, so we would have the data in S3 bucket or some other places. Okay, so if I need to use that metadata or the data that needs to be read as a tabular format from that source, in that case, that has to be bundled with the Glue data catalog. The Glue data catalog is something which holds the metadata information of any files or tables as such, which can be used in Glue ETL jobs. Okay, so for example, if I try to draw the similarity with Apache Spark and Hive, right? So Apache Spark has something known as the Spark data catalog, and Hive has something known as the Hive data catalog or Hive metastore, right? So how Hive used to store the metadata information is that whenever I'm creating an external table on Hive, right, and I'm pointing the location to where the physical data resides, but the schema, column name, and all the metadata information is stored in slash user slash hive slash warehouse rate, right? So that's the metastore or repository for Hive, and that is the Hive catalog. Similarly, if I talk about Spark, so I can use the same tables or I can use the actual physical files as well that is residing in Hadoop cluster or any any storage for that matter. I can either directly read the file from the Hadoop, or I can read the table that is already created on top of that file in Hive. There are two ways I can read the data, right? So when I'm trying to read the data using AWS Hive, using Hive into my PySpark, that time I'm using the Hive metastore or the Hive catalog for the metadata information, right? The schema, the columns, and everything. But when I'm trying to read the actual files from the Hadoop cluster, then in that case, it is not using the Hive metastore. Instead, it creates its own catalog, that is the Spark catalog. Okay, and Spark catalog is automatically created whenever you read a data from Hadoop and then create a data frame out of it. So similarly, in AWS Glue, the Glue ETL jobs can try to read the data from the Athena tables, which I showed in the previous example or in the previous session, that how can we create Athena tables on top of the S3 data. So either that, or I can read the data directly from S3. Okay, no need to create a table as such. So similarly, these two ways I can read the data in and out from S3. And when I'm reading the data from the S3, or when I'm suppose reading the data from the Athena table, so in both the cases, it is using the Glue data catalog, right? So what is AWS Glue Data Catalog? It is, as I just said, centralized metadata repository for all data assets, automatically updated via AWS Glue crawlers. Okay, so that we saw an option, right, when we are creating the crawlers, that we can only crawl upon or scan upon the newer data or the later added partitions, just to include them as well in the Hive metastore, sorry, in the Glue metastore or the Glue data catalog, or else we can scan the whole data. So the thing is, it can work both ways. So automatically, whenever the new data is updated in the S3, in that case, the glue crawlers will, the glue crawler, through the glue crawlers, it will, the data catalog will automatically update it. Used by services like Athena, Redshift, and Lake Formation. So we have already seen how do we use in Athena. Same can be used in Redshift as well, even though it's out of the scope for this course, because Redshift itself is another huge domain that comes into the data warehousing part. Okay, now if you go back to one of the very old sessions where I have demonstrated the difference between data lake and data warehouse. So data lake is the thing that we our primary courses emphasizes on, right? And data warehouse is something where the structured data is there, and there are different other sort of things that goes on. It's not nearly part of the data engineers. Data engineers work is limited to putting the data into data lake or in some form of data warehouse. Okay, and then there is lake formation as well, which is another service that uses the Glue data catalog. So over here, we're gonna mostly focus on the Athena tables, and obviously when I'll be show you the live example, I will cover a couple of S3 options as well, how we can directly read the data from S3. So the second component is the glue crawlers. Now it is, we have already seen, right, how it works. Scans and discovers data sets from different sources, automatically populates the glue data catalog with schemas and metadata. So glue data catalog is there. Once you put a file in the S3 and then you run the crawler, the glue data catalog will be updated with the latest metadata information that comes along with the file. It's easy as it is. Right, now coming to the third one, that is the glue jobs. This is where our this session primarily focuses on. So we can create ETL scripts that is written in PySpark or Scala that transform and move data. It can be scheduled, triggered by events, or run on demand. Okay, so it has two kinds of jobs basically. One is the batch jobs, the other one is the streaming jobs. Streaming jobs, we can use either Kinesis or Kafka, and batch one is simply reading the data from Athena and S3. Okay, so so the way we understand is the glue jobs is nothing but it comprises of the scripts, and the scripts will have the PySpark code written on it, and we just the glue job, that PySpark code itself, that script itself is the AWS glue job. Okay, so when I create a Spark application, right? So when I create a Spark application, so that consists of my PySpark script, right? And that PySpark script itself is a Spark job. Then I can run it on any environment I want. Similarly, over here, AWS Glue jobs are nothing but the ETL scripts that will be written in using the AWS Glue service. Okay, I can either written on a different IDE such as PyCharm or anywhere else, and then I can upload the script in AWS Glue job, and then I can run it from there. It's pretty easier to understand. But there are some native differences between the normal PySpark API and AWS Glue PySpark. So let's take a look at that. Okay, so now we are introduced with a new term, that is dynamic frames. Now, what is dynamic frame? We have heard about data frames, right, using the PySpark, but let's come to dynamic frame now. A dynamic frame is similar to a data frame, except that each record is self-describing, so no schema is required initially. Okay, so this is pretty much a bit complicated phenomena, right? That no schema is required initially. What does it mean? Okay, so, okay, let's take a look at an example. So, AWS Glue computes a schema on the fly when required and explicitly encodes schema inconsistent using a choice or union type. Like changing requirements and address columns stored as a string in some records might be stored as a struct in later rows. Rather than failing or falling back to a string, dynamic frames will track both types and gives users a number of options in how to resolve these inconsistencies, providing fine-grained resolution options via resolve choice transformations. So, uh, let me just summarize this whole thing. When I'm using data frame API in Apache Spark or PySpark, so what it does, when it initially reads the data, it will try to schema automatically, scanning the data. And then if I try to print the schema, it will show me the data types of each and every column based on the inferred schema, okay, that PySpark could achieve. So which means, suppose there is one column that is already in string. I mean, for the first 10,000 rows, it is string, and then suddenly after some time, it changes to say struct. Okay, so what's gonna happen in that case? So suppose there is one column which is already integer, and then some later rows there are some strings. Then PySpark will automatically infer that column as a string column, because integer string can handle numeric columns as well. Meaning, if I just put the numeric values in under quotes, in that case, that will be treated as string. But there are some struct columns, meaning there are some array columns or something like that, or in JSON format columns. So if I try to read that file or read that column using normal PySpark API, it will fail because it won't be able to understand the schema. Because whenever you see, I mean, I'm not sure, like if you have seen in pandas or anything, pandas also has this ability to handle different kinds of data types. Okay, so I myself have faced this in real world projects. Is whenever there is a pandas data frame and I try to convert into a PySpark data frame, I see there is a bit of a discrepancies between two different data types in the same columns. Okay, so what I have to do, I have to enforce the schema for that data frame when I'm trying to into a PySpark data frame, and that only it works. But if I try to read the same data in or try to convert the same data frame using the glue data dynamic frame, in that case, there is some option that it can handle automatically. So it will give you an option whether to cast it or whether to create separate columns for different row values for different kinds of data types. Okay, so there is one method called the resolve choice, which allows you to manipulate the column or manipulate the data in the way you want. Okay, so it has some options. First one is the cast, and it's similar to the PySpark API. Allows you to specify a type to cast to, for example, cast integer. Then there is, so this means that I want to enforce this casting to that particular column, right? And only those will be there. The rest all will be null. I mean, those which are for which the data type is satisfied, right? If there's one address column which has some string and then later rows are struct, in that case, if I cast it as string, in that case, the latest struct rows will be automatically evaluated as null, right? Second one is the make calls. Resolves a potential ambiguity by flattening the data. For example, if column A could be an int or a string, the resolution is to produce two columns named column A int and column A string in the resulting dynamic frame. Okay, it's pretty self-explanatory that it's basically dividing the column into two, and one will be having the integer, the other one will be having the string. Now, the coming the make struct resolves a potential ambiguity by using a struct to represent the data. For example, if data in a column could be an int or string, using the make struct action produces a column of structures in the resulting dynamic frame which contain both int and string. Okay, So this means it will simply create a JSON formatted dictionary that is the struct column, and it will have both the integers and the strings. Where the integer is applicable, only integers will be there. Where the strings are applicable, only strings will be there. And there's a project resolves the potential ambiguity by retaining only values of a specified type in the resulting dynamic from. For example, if data in a choice type column could be an int or a string, specifying the project string action drops values from the resulting dynamic frame that are not type of string. Okay. So what's the difference between project and cast? In the cast, if you cast it as integer, then the string values will automatically convert it to null. But whereas project, you're not only enforcing the schema, but you're also making it clear that you don't want the columns that are not conforming to that particular data type, right? So whatever are string, those will be automatically dropped or removed. So that is the main difference. Otherwise, it works the same ways. And similarly, make calls and make structs works the same ways. One will give you separate columns. The other one will simply put into one column with different values. So that's it from this session. In the next one, I will show you one live example of how to run Glue ETL job using the Glue services, and also I will show you some examples of the dynamic frame in the notebook using the AWS Glue. Hopefully you have understood and you've been going through all the sessions and all the videos without having any sort of issues. If you have any concern or do you need some much more clarity, just you can reach out to us. We are offering this course where we cover all the necessary tools in our data in all the necessary tools such as Spark, Hadoop, Hive, AWS with hands-on coding and real-world project. And we also offer 100% job assistance. We will create a resume for you, including the projects and everything that you will be working upon, and and it will make your candidature absolutely rock solid. So just reach out to us for any help, and I will be signing off from this session. See you next. Bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.